Alright, boys and girls, welcome back to the drive-thru for a special remix edition. This is Mr. Euland talking over my previous video that didn't have audio, so let's get it going. As always, the drive-thru is sponsored by the deli. Hungry? Stop by the deli. Get yourself maybe an Italian sandwich on a brioche bun. Alright, so this is 7-1, triangle application theorems. Okay, you got 3 new theorems coming your way. 2 of them should feel like you've already learned them months, if not years ago. One of them will be probably brand new, involving some brand new vocabulary. So let's get going. The first theorem is called the triangle sum theorem, which you hopefully all know. And that says that the 3 interior angles of a triangle will always add up to be 180 degrees. Okay? But let me show you how we could prove this theorem. We could say there exists a line that travels through point B that is parallel to AC. Okay? Kind of like those crook problems. Do you remember what the crook problems looked like? You would have something like this, and you would say, how am I going to do this problem? And you'd say, well, if I drew another parallel line through that point of intersection, then that would really help me solve that problem. So that's kind of what we did here. So we added a parallel line, and now we've created 3 angles that I'll label angle 1, angle 2, and angle 3. But we have already declared that the blue line is perpendicular to AC. Is parallel to AC. So by alternate interior angles, we can transfer angle 1 and angle 3 down. And we know that angle 1 plus angle 2 plus angle 3 equals 180 because a straight line is 180. And since angle 1 plus angle 2 plus angle 3 equals 180, we have proven the triangle sum theorem. Here's the next one, the triangle exterior angle theorem. If we have a triangle with one side extended to create a single exterior angle, the measure of the exterior angle is equal to the measure of the remote interior angles. Okay? So what we're going to do is we'll just refer to this as angle A, this one as angle B, this acute angle here as angle C, and then this supplementary angle, which is obtuse, it appears to be obtuse, I should say. We're going to call that angle 1. Check out this proof. So from our previous triangle sum theorem, I know that the sum of the angles in a triangle are 180. However, I also know that a linear pair, a pair of angles that forms a line, also equals 180. Notice that we have 2 equations that are both equal to the same thing. So by transitive or by substitution, I could say that angle A plus angle B plus angle C is equal to angle 1 plus angle C. Now I can subtract angle C from both sides, because I'm allowed to do that, because you can subtract the same thing from both sides of any equation. And now you will get your result that you're trying to show, which is that angle A plus angle B is the same as angle 1. Alright, now, let's say angle A was 70 and angle B was 40. What we just learned is that angle 1 is absolutely 110 degrees. No doubt about it. One more theorem. Now this is new. Okay, so the new word is called a midline. What is a midline? It is a segment, and it's a segment that connects the midpoints of 2 sides of a triangle. Well, why would you ever want to do that, you might ask? Check this out. So if this pink dot is the midpoint of this side, and then this green dot represents the midpoint of another side, and then if we take those 2 endpoints and create a segment from them, the midline, that is a midline. We just made a midline in black. That midline is parallel and half the length of the third side. Crazy. Cray. So I like that little fact. And the book is going to kind of ask you to prove it, so I won't save all your enjoyment and challenge. I'll leave some of that for you. Let's do one type of problem that you'll see from this section here. This is all the information we're given. We're asked to find the measure of angle I. We know that angle M is 80 degrees, and we know that LI and KI are angle bisectors. Well, let's just start out by naming these things. Both of those are congruent to each other, so we can call them both x's. We can call both those y's. And we know that 2x plus 2y plus 80, well, those are the angles in the red triangle, so that has to equal 180. However, we also know that the angle x plus angle y plus angle I also equals 180 because this thing down here is also a triangle. So we have two different triangles, so we set up two different equations. We're trying to isolate angle I. Well, let's use a similar strategy to last time, and since both of these things are equal to 180, then we can use transitive, or you could call it a substitution, to say that 2x plus 2y plus 80 is equal to x plus y plus I. All right? So if we subtract x plus y from both sides, or subtract an x, subtract a y, we will get angle I equals x plus y plus 80. It doesn't exactly help us. It's true. We might use it down here in the future, but right now that's not what I'm looking for. I think I can get an answer. Now, one of the problems that we have here is that we have three variables, and we only have two equations. So this could be a task that could be too daunting for us, but we don't really need to solve for all the variables. The only variable we need to solve for is what is angle I. So let me try to divide this whole pink equation by 2. That'll give me x plus y plus 40 equals 90. And then subtracting 40 from both sides, I'll get x plus y equals 50. That's what we needed, because now we can take out x plus y in this equation, and we can substitute in the number 50, because x plus y definitely equals 50. So now we know that 50 plus 80 equals I, and I is 130, and that is that. Boom!